All right, so we are almost finished with our distribution network. You may think, distribution network? That's right. We're talking about the network that creates all of our points in which we will be distributing our spheres to. In this video, there's one final thing that we need to fix. Now, you may be thinking to yourself, what do we need to fix? We've already given an artist a lot of control. They can go in there and specify a maximum number of balls per bench. They can specify if we're going to have random empty seats or not. We can control the bias nicely so that as our benches get smaller and smaller, we don't try to cram such a crowd onto the bench itself. And finally, once we have the number of benches that we like basically being set up, in other words, most of our numbers set up the way we like, we can simply go through different seeds and take a look at different distributions throughout the stadium until we find one that satisfies our project's needs. What could be broke? Well, let's take a look at this. Anytime we have a single point in which we're going to copy a character to, where is he on the bench? All right, he's center. He's center. He's centered. He's centered. He's centered, 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 centered. Okay. What if we have an odd number of points? Where's the middle point at? Centered, 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 centered. Everything is centered. We need to start offsetting our points one way or the other. Otherwise, the more characters you add into the audience and the more columns you have, the more apparent it will become that we've got everybody centered on the benches.
And we've been pushing for randomization and we'll continue to push for randomization in terms of numbers of points, and we're going to push in terms of the shader and the animation. So the last thing we want is to break that effect by having something that's uniform in terms of overall placement.
Exactly. So how are we going to do it? Well, let's jump over here to the whiteboard and let's quickly come in and add a new layer. There's the hard way, and then there's the easy way. I'm going to just talk about the hard way, but we're not about to tackle that because this is still the introductory video into the entire TD series. The hard way would be as follows. I'm going to take my points, let's say I've got 4 points, and I'm going to randomize. I'm only interested in all the inside points because I'm still dealing with my curve before we delete the 2 outside points. I'm going to just randomize my location of points. So maybe take this guy and move him over to right there, and this guy maybe over to right there. Oh, that's fine. That'd work great. Let's take a look at another curve. So here's one where we've got one. Well, first of all, we know that we start out with equal spacing between everybody. So what if I randomize this guy over just a little bit, move this guy over here to about right there. So we've got him, and then had another, no, that's the same type thing, but that'll work. So now let's give these guys some radiuses. Radii. That was great. So here's this guy. Here's this guy. That's fantastic. Let's give him a home over here on this curve. There's this guy. Ooh, there's this guy. We've got 2 characters that are now intersecting. Okay, not a problem. Now, before we start manipulating the location of these points on the curve, we now need to think about the radii of the character that's our neighbor that we're moving towards. Ugh.
Yeah.
That becomes much more difficult.
It becomes extremely complicated because you have to take into account the positions of the neighboring points, the size of the sphere that's being copied to that point.
And your size?
Yeah, and the number of points on the line, and a huge amount of information to take into account.
Exactly. But fortunately, we can still come up with a very elegant solution that gives the appearance of a very randomly distributed crowd. And here's how we're going to do it. Let me go and clear all this out. And let me redraw a curve. All right, that's it. We're going for the shift button. Ah, much better. And this guy is going to be centered up, so somewhere around right there. And he's going to have a total of 4 points. If we took the entire curve, this entire line, and we offset it this way or this way, and as we work our way up our rows, everybody randomly gets offset one way or the other. So 2 guys, 2 different rows back to back may go to the left, and the next one may be to the right, and then the next one may be back to the left. what's going to happen is we're going to break the illusion that's so apparent. Actually, it's not illusion. We're going to break the fact that everything's centered, okay? Because at this point, nothing is no longer centered. But we got to be careful. Here is the end of our bench. So how far are we going to move? What would be a safe amount? How about if we were to calculate a segment length? The segment length being the distance between any two given points that are side by side, okay? Because we know that with the line, as we add or take away points, the distance between each of our points will always be the same. So if we calculate a distance, when this endpoint and this endpoint is removed, now we're just left with this guy and this guy. If we were to move a segment's length, the furthest we could move to the left by a segment's length would be back to right here, which is still safe from hitting the edge. The most we can move if we were moving over in this direction would be to right here. Once again, we have a safety buffer before we hit the end of our bench. So we need to be able to calculate our segment length. How do we calculate our segment length? Well, we have a distance parameter, and that distance parameter tells us how long this guy is. And we need to take that and divide it up by the number of segments we have. But we don't have a segments parameter. Who cares? It's very easy to figure out. How many segments do we have? 1, 2, 3, right? How many points do we have? 1, 2, 3, 4. So if I take one of those away, 1 point away, we'd have 3 points. Those 3 points, that would represent our segments. Let me give you one more proof. 1, 2, 3, 4, 5, 6. How many segments do we have? 1, 2, 3, 4, 5. That means we're going to have number of points will be equal to the segments plus 1. Let's find out. 1, 2, 3, 4, 5 plus 1, 6. So if we simply take our points, so we can simply reference our points parameter and we subtract 1 away from it, we now have a number that represents the segments. If we divide that into our total distance, that is going to give us the length of each segment, okay? Because once again, we know that the length of each segment is equal. Fantastic. So let's just say that this is equal to B. Now, this will have us offsetting in a positive direction because it's going to end up being a positive number, but we want to be able to offset either positively or negatively, and we want that to be randomly decided so that we don't have to worry about it. So basically, if we were to take B and multiply B by rather a positive 1 or a negative 1, then we would end up going, well, exactly as we have drawn here. Negatively by a segment's length or positively by a segment's length. So how are we going to generate the positive 1 or the negative 1 randomly for us to use as a multiplication number for this distance over points minus 1? Simple. We've all seen good old rand. So let's bring rand back into it. Now with rand, I'm going to once again generate a unique ID for every single row for every single column. Very important. We don't want any of our numbers to start coming up into a pattern. The moment it comes up into a pattern, we're away from a randomized look. We already know that we can say, look, let's take our current row number and add to that our current column number and multiply that by our number of rows. And this is going to give us, this inner portion right here, is going to give us a truly unique ID for every single row throughout our stadium. But we would like for the artist to have some sort of say in the look of this. So what if we were to create a new custom parameter? So I'm going to give myself a little bit of space up here and create a custom parameter for an artist. Let's just write it over here. And we're going to call it something like offset seed. Outstanding. Now just keep in mind, this is just like the seed that controlled the overall distribution. It's not a number that an artist can start tweaking with his eye on a very specific row and watch it slowly slide left or right. This is just changing the overall randomization look of all of our points being shifted left or right. That's all that's going to apply or take place here. So if I take the value that an artist enters into that number and multiply that down here,
and we do want to make sure we multiply all of our unique ID, so we're going to need some brackets.
So we're going to need just a few because this guy right here could end up messing everything up for us.
Awesome.
There we go. Finish off our rand. And this will give us unique ID. Take unique ID, multiply it by this guy, and that gives us a result, as we all know, of 0 to 1. Now, it is a number between 0 and 1, but since it can get so close to 0 and so close to 1, let's just stipulate it's 0 to 1. So 0 to 1. But wait a minute. I need this to go from a negative 1 to a positive 1. So now, so that I don't have to continue rewriting this entire thing out, what if I was to just subtract away? So if I had this rand, and this, which we shall now call B.
We've already got a B.
Do we have? Oh, we shall call C. Thank you very much, Steve. So if C was in here, so if we were to take this rand, and then with that, I was to subtract away 0.5, what's that going to give us? Well, 0 minus 0.5 is going to give us minus 0.5. And 1 minus 0.5 is going to give us 0.5. So now we've created a range of negative 0.5 to 0.5. Closer, much closer. If I take this, the result, and multiply that by 2, I've just scaled the 0.5 up, and that is going to give me a value of 2 times this is going to give us a negative 1 up through, and 2 times 0.5 is going to give us a value of 1. There is what we're looking for. So if this guy right here represented D, I could then just come back up and say that A times D, looking for an eraser.
And that would be B times D.
Or B times D. I don't know why I keep...
We skipped A for some reason, but it's all good.
I know, I don't know why, but what's interesting is mentally... I think I wrote A down, and so I keep going back.
Yeah, because then we had B for the other, but yeah.
I know, it's really weird.
It's kind of crazy.
So if we take this guy and we come back and just simply say B times D, now, what are we going to do with that? Well, if you recall, with our offset X, all the way back at the very beginning, we had set offset X, I'm just going to borrow this space right in here to write with. We had said that offset X was going to be equal to, I believe it was something like, let's take our distance, and divide it by 2. So that centered us up on the origin. That gave us this right here. So we're centered up. If we take that and this new number that we've just generated, we just simply say take B and multiply it by D. So these two guys right here. So remember, that's just basically saying take our segment length, so I'll just put seg L, and multiply that by rather a positive 1 or a negative 1.
Exactly, and that positive 1 and negative 1 is a range between those values, which means the maximum we're going to move in either direction is our segment length, but we can move anywhere between there, so we might not move at all, we might move a little bit to the left or a small amount to the right.
That's right, because
everyone's randomized.
That's right, because the random, again, as I did with the arrow right here, is a range between that. So it could have been 0.3.
Exactly.
Could have been negative 0.4. But I'm just representing we're going positive or we're going negative. And so that's pretty much it. That's going to give us the offset we want, and then that will allow an artist to go through and pick the offset that looks best with all of the other settings he's applied to the crowd that's being distributed around to his stadium. So with that, I guess we can go ahead and jump over into Houdini real quick and put all of this together.
Awesome. So I'm going to jump over into Houdini. and close out our parameters. And before we get going, let's create that new seed that we're going to need for this expression, and that's our offset seed. So I'm going to right click on our bleachers, come down to type properties. Into our audience folder, I'm going to create a new float parameter, which I'm going to name to offset seed. Offset seed. And I'm going to place this beneath our other seed. And like with our other seed, where we locked between 0.0001 and 100, I'm going to do the same for this guy. And 100.
Okay.
And accept that out. So we're going to be on our audience template line, and we're going to be dealing with our origin in X. So I'm going to bring this up in an expression editor, since we're only going to deal with this one parameter for the rest of this video.
Okay.
And we're going to add to this a random number multiplied by our basically our segment length. So on the whiteboard we had segment length first and random number second. So let's do that here in this expression. So we saw our segment length is our total distance divided by our number of points minus 1. So let's take our distance parameter and divide that by our number of points minus 1. And I've put that in brackets to make sure that this gets evaluated before the divide. So we've got this guy, which I'll put into brackets. So that's our B over on the whiteboard. And we now need to calculate D, D being our random expression and the scaling on the random as well. So let's just deal with the random expression first, and then we can deal with scaling this guy up. So our random expression uses our unique ID. We've seen this before. It's our row number plus our column number times the number of rows. It's going to be fairly lengthy due to the stamping involved, but it's nothing different than what we've seen already. And then we're going to multiply that by our new seed parameter.
Okay.
So let's jump back to our expression, and we're going to multiply B by, let's start constructing D. So we're going to use a random expression. And that random expression is going to take our column, well, our row number to begin with, which is going to be stamped from...
Our row num, not number, so we don't have another typo.
So copy benches for rows. And we're going to grab row num and default that out to 0. So that's our row number, and we want to add that to our column number times the number of rows. So add our column number, which is on our copy columns, and was the column num parameter with a default value of 0. And we want to multiply that by our number of rows, which is up on our asset.
Okay.
So that's our unique ID. And we want to take that unique ID and multiply it by our new seed parameter. So I'm going to put this in a further set of parentheses. So that closes off that one. That will close off our stamp. Let's clean this up a little bit. There we go. And multiply all of this, which is still inside the rand, by our new offset seed. So that's going to be multiplied by offset seed. Fantastic. So that's our random number, but the random number currently goes from 0 to 1. So let's take our random number fairly lengthy, and subtract from that 0.5 and take all of that. You can see the entire random expression minus 0.5 in brackets, all of that, and multiply that up by 2. So we're going to take our random number, to take 0.5 from it, so that it goes between minus 0.5 plus 0.5, multiplied by 2, so it now ranges between minus 1 and plus 1. We're going to multiply that in by our distance over number of points minus 1, so our segment length. This is then going to give us a positive or negative offset that we add to our original centering. So,
yeah, fingers crossed.
Yeah.
I just want to throw in one thing real quick. As you were starting to type this out, I was kind of spending a second going over in my head what I had said on the whiteboard. And I realized you had come in to make sure that everyone was very clear as to what I was saying, because I had got on the whole kick of saying 1 to negative 1. I just want to make sure everybody realizes and the reason I continue to point out 1 and negative 1 is because I want everyone to know that we're going all the way up to that segment value negatively or positively.
So but either all the way up to here, all the way up to here.
But it's not all the way, it's up to, meaning that we've got
a range. So we can take from our center, we can shift up to here, or we can shift up to here, and we can sit anywhere between these two.
That's right. So while for drawing it out, it's very simple to just draw a positive 1 or a negative 1 just to represent, and to represent us moving in a positive or negative direction. But just keep in mind that is a value from a fraction of a hair above 0 all the way to -1 or all the way up to +1. So
yeah, anywhere between those two values we can sit, and that's going to basically mean that anywhere between
fraction below 0. That's so funny.
That's funny.
I'm staring at the rand right now. It's the bottom line is we can move from -1 to +1.
Which is going to shift us left or right between this point or this point.
Exactly. Wow.
Awesome.
Okay.
So yeah.
So yeah, back to fingers crossed, and does it work? Yep, it does. I'm already seeing offset.
I do want to... There we go. I'm in the top view. That's why I can't rotate around. So let's bring up a perspective view. I was like, Actually, that doesn't help. But right, let's go back to a top view.
You can't see it. I can see it already.
I can see.
It's looking good.
Yeah, and nobody's getting offset over to the... too far off the edge of the bench. You see the maximum they're ever coming up to is where we'd created our line to anyway. And you can see that now we're losing that feeling of everyone being centered up. So let's bring up our parameters. And let's just change this offset seed around.
Look at that.
So now we have a lot more flexibility and a lot more control over the positioning of our points. And with that, we've now created all of the templates that we're going to use to copy our audience members to. So we no longer need to be worrying about these lines and these points. And in the next couple of videos, we're going to be dealing with copying the sphere geometry to these points.
Outstanding. And with that, that's going to conclude this video. Thanks a lot, guys.